Questions on any of the homework assignments so far? Huh? We started this yesterday. Our homework from 7.1, 7.3.1, or 7.3.2. Because we haven't finished 7.4.1 yet. Because we did this one yesterday. But we can look at it again. Yeah. And the first thing we do with adding or subtracting rational expressions is we need to get the denominator to be the same. But in order to do that, we need to make sure that each of the denominators is factored as far as it'll possibly go. So it's going to make it easier for them to be the same. Because 9x squared, a single term, so it's just going to be 9x squared. Now if we look at our other denominator, 3x squared plus 3x, we can't factor it with two sets of parentheses, but both of these terms have a greatest common factor of 3x. And we can factor the 3x out of 3x squared and 3x. Because if we factor it out of 3x squared, we're left with x. Plus, when we factor 3x out of 3x, we have 1. And that's as simplified as it gets. All right, flip out the rest of my pins. Now that we have a factor, we're going to find the least common denominator. We're going to find the expression that will make both of these be the same. And we're specifically looking for the smallest expression that we can turn both of them into. Now, our smaller expression will not be less than either one, because with 3 and 9, the least common denominator will not be less than 9. We've got to go to at least 9 or bigger for them to be the same. And what is the first number with the factors of 3 and the factors of 9 that we can make them both be? Because we're going to want to go up, not down. Because what's the first number we can turn both 3 and 9 into? Well, let's look at the factors. Factors of 3, our prime factorization is 3 and 3, and 3 is just 3. And again, with least common denominator, we take the most of each of the factors in each number. So we look at 3 and 3 squared. They both have 3. One has 2 and one has 1. How many factors of 3 are we going to need to take? 2. So 3 squared. So we have 3 squared. Now we look at our x squared and x. One of them has 2, the other has 1. So we need to take the most of each of these here. So we're going to take x squared. And the only other thing left is our x plus 1. So it's 3 squared times x plus 1 is the least common denominator. It is the first thing we can turn 9x squared and 3x times x plus 1 into, and then be the same. Now we can simplify this a little bit because 3 squared is just what? 9. 9x squared times x plus 1 is our least common denominator. The first thing we can make both of these denominators be. So when we go to add them, we need both of the denominators to be x squared, 9x squared times x plus 1. We need both of them to be this so that we can add these together. Now to do this, we need to multiply both of these by a certain expression to get there. Now the one on the left, it has 9x squared already. The only thing it's missing is x plus 1 to get these to be the same. And our 9x squared times x plus 1 is 9x squared times x plus 1. Now the numerator, we can multiply both of these terms by 7. Our 7 times x is 7x. Our 7 times 1 is plus 7. So that's taking care of the one on the left. The one on the right, we have x plus 1 already. But we have x instead of x squared. So we have to multiply the top and bottom by x. This one here we have 3. We need it to be 9. Well, we also need to multiply it by 3. Because our 3x here, this 3x and this 3x will multiply together to give us our 9x squared, making the denominators be the same. But we also have to multiply the numerators, x and 3x, giving us 3x squared. Questions on this here? Now at this point, we can add our two numerators together. We're adding our 7x plus 7 and our 3x squared. Now we can reorder this so that we have it in standard form. Guys. Now at this point here, we need to see if we can factor the numerator at all, if there's a greatest common factor, if we can do two sets of parentheses. And at this point here, 3x squared plus 7x plus 7 is its simplest form. There is no way to factor this down any further. So this here is our final answer. We did. But I'm going over it again just so we can see it. All right. This one here is the first one that we're doing today because we did the other one yesterday, but we're going to go on and look at this one here today. I need to get your note sheet out. Possibly over there. Now the first thing we need to do is factor our denominators as far as we possibly can. One of them is 12x squared. Well, 12x squared, it being a single term, does not factor any farther than it already is. Now the one on the right. Now, our x squared plus x. We have two terms, so we're not doing our normal two sets of parentheses with 3 spaces. But x squared and x do have a greatest common factor of x. And if we factor the x out of x squared plus x, our x squared becomes x. Our x becomes 1. Removing an x from both terms. And we get this here. Questions on any of this so far? Questions on anything we've done so far? Now at this point here, we need to find this least common denominator. We need to find this expression that will make both of these terms be the same. It'll help us get what the two denominators need to be. And the first thing we can look at is the numbers in front, our numbers outside of our parentheses. One of them has 12, one of them doesn't have a number there. So it's understood to be 1. Well, let's do our prime factor. Well, we can do our prime factorization with 12, which is 2 and 6. 6 is 2 and 3. So this here is 2 squared times 3. The other one is 1. I'm going to move that a little farther over. Well, prime factorization of 1 is just 1. So if we take the most of each one, 1 doesn't do anything, but we would still have 2 squared times 3. And that's it. Now we can look at our variables outside the expression next. X squared next. The one on the right has 2 x's, the one on the left has 1. And if we're taking the most of each, we're taking the x squared. And that's everything accounted for here. The only thing else that we have is the x plus 1. Since we have 1 in one of them, we need it as a part of our least common denominator. Questions on how we got this here? Now our 2 squared times 3 is 12. So the least common denominator, what we need to turn this into is 12x squared times x plus 1. And we're going to have to multiply both sides by something to get it there. Now the one on the left, our 12x squared. Well, the least common denominator does have the 12x squared. This side's just missing x plus 1 on top and bottom. And when we multiply these together, we do get 12x squared times x plus 1. The numerator, we're going to distribute the 8. 8 times x is 8x. 8 times 1 is plus 8. The right-hand side, we already have the x plus 1 and x, but we don't have the 12. And we only have x to the first, we don't have x squared. So we need another x. And on the right-hand side, again, we're going to multiply our 12x times x plus 1. We're going to multiply our x and 12x. And x times 12x is 12x squared. And we still have times our x plus 1. The numerator, x times 12x, is 12x squared. Questions on this here? Questions on any of this so far? Now at this point here, since the denominators are the same, we can add the numerators. We can add our 2 numerator terms together, our 8x plus 8 and our 12x squared. Now at this point here, we're going to rewrite it in standard form. And we get this here. We cannot cross out the 12x squared and 12x squared on top and bottom. Because in the numerator, 12x squared plus 8x plus 8, that is one term. They're all connected together. We can only simplify out if 2 things are being multiplied. And those multiplications are the same on top and bottom. But there is some simplifying we can do here. Because if we look at our numerator, 12x squared, 8x and 8, is there a greatest common factor between these 3 terms? 12, 8, and 8 has a greatest common factor of 4 that we can factor out. Because if we take the 4 out of 12x squared, we have 3x squared. If we factor 4 out of 8x, we have plus 2. Now these we can simplify. Because our 4 over 12, 4 is being multiplied with our 3x squared plus 2x plus 2 now. Our 12 is being multiplied with our x squared plus, or x squared times x plus 1. 4 over 12 is what? One over 3. So we have 3 in the denominator. the numerator is still 3x squared plus 2x plus 2. We do have a multiplication of 1 here, but we don't have to write it. It's understood. So we have this here, because if there is something that reduces, we do need to reduce it. Questions on this here? We ready for the next one? Find the difference. And again, the first thing we need to do before we find the difference, before we add or subtract or do anything else, we need to factor all the denominators. We don't have to worry about the numerators, but we do need to factor each denominator. And when we factor again, we look for greatest common factor first. 2x minus 2 has a greatest common factor of 2. Because if I factor the 2 out of 2x, we have x. When I factor the 2 out of 2, we have 1. So we get 2 times x minus 1. Now we're going to look at x squared minus 4x plus 3. When we factor this here again, greatest common factor, there's not one. We find the sign. Since the third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. Factors of x squared, x and x. And our factors of 3 are 1 and 3. There's only one set of factors. Now, if we want to make sure that this is correct, we can check. And we can do this off to the side. X times negative 3 is negative 3x. Negative 1 times x is negative x. Gives us negative 4x. That is the middle term we wanted. So that step there is just to check and make sure we have it set up correctly. Questions on any of this here? Okay. No questions, no questions. Now, we need these denominators to be the same, because if they're not the same, we cannot add or subtract. The only way we can add or subtract fractions is if the denominators are the same. And at this point here, to find it, find what's going to make them be the same. Well, let's look at any terms that are outside, any of the or greatest common factors, any of these terms that are outside parentheses first. The one on the left has a 2, yes? The one on the right, there's not one, right? Well, what happened to the 12 in the last problem? 12 on one, nothing on the other, it just became 12, yes? So here, since 2 is the only one, it's just going to be listed. So we don't necessarily, especially if it was 12 or a bigger number, have to do all the factors. If that's the only number, we can go on and list it as part of the least common denominator. Now we can look at our parentheses. The one on the left has an x minus 1, has one of them. How many does the one on the right have? 1. One of them shows up in both, yes? So our least common denominator should have it only once. The only way we'd have it more than once is if one of them had it twice. Because if there was an x minus 1 that showed up twice in one of them, then we would need it twice. Because it only shows up once, we only need it once. Well, that takes care of everything on the left for least common denominator. On the right, we also have n almost x minus 3. Since it shows up once, we do need it contained in both, yes? So if we look at this here, the least common denominator, when we get these to be the same, both of these should be 2 times x minus 1 times x minus 3. Because for these, for us to be able to add or subtract, these have to be the same. They have to be the same for us to be able to add or subtract these. Okay. Questions on this so far? Questions on anything we've done? Now, to get them to be the same, we do have to multiply both of these by something. Let's start on the one on the left. Least common denominator, getting down here. It has the 2. It has the x minus 1, but what's it missing? So we have to multiply top and bottom by x minus 3. Let's look at the one on the right. It has an x minus 1. It has an x minus 3. So is it missing anything? It is missing one thing. The 2. Because it doesn't have a 2 in front. So we have to multiply top and bottom by 2. Questions on this here? Now out of these two here, trying to do this multiplication one step's a little bit much at times. Because we're going to multiply these two here, because we're going to have our x minus 3 times our x plus 2. So we're going to write this down and then multiply. Here, we're multiplying our 2x minus 1 by 2. Yes? Well, what's 2 times negative 2x? Because 2 times negative 2 is negative 4, and we have our x. 2 times negative 1, negative 2. Because we're just multiplying those two by 2. Here, we do have to multiply this out, because if we're going to subtract, we're going to have to combine like terms. So we need to multiply this out and simplify. X times x is x squared. X times 2 is plus 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. Now at this point here, we do need to combine like terms. 2x minus 3x is negative x. Questions on this here? Now at this point, we can subtract our numerators. Now this is the first one where we're subtracting and we have more than one term in our numerator, especially our second one, the one we're subtracting. And we really need these parentheses when we subtract. Probably don't need that much, but it's going to help us out. Because with this second one, the 4x is not the only one this negative affects. Because when we subtract a negative 4x, the negative and negative make it positive. When we subtract a negative 2, it's the same as plus 2. Now our first term is going to stay the exact same because there is no sign in front of it, so it's understood to be plus. Signs don't change. Sign is only changing with our terms we are subtracting. Now we can combine negative x and 4x are our first set of like terms. X squared does not have any, so it'll just be x squared. Our negative x plus 4x would be plus 3x. Our negative 6 plus 2 is minus 4. And we get this here. Questions on any of this so far? Now the last thing we need to do before we call this finished is we need to factor this numerator. X squared plus 3x minus 4. This one is the first one we've had that actually does factor. And again, an easy way to check with quadratics is our b squared minus 4ac. And this is again referring back to our ax squared plus bx plus c. So in this case here, our b term is 3. 3 squared minus 4. A, the number in front of x squared is 1. C is negative 4. If this gives us a number without a decimal, then it is factorable. 3 squared minus 4 times 1 times, make sure, negative 4. And we get 5. Since we get a whole number without a decimal, it means our x squared plus 3x minus 4 factors. We're going to factor it. Since our third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Factors of x squared. All the things that multiply together to be x squared are x and x. Since there's not a number written in front of it, we're not worried about those factors because it's just the factors of 1. Factors of 4. 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4. And again, we can check this off to the side to make sure we have it factored correctly. X times negative 4 is negative 4x. 1 times x is plus x. And negative 4x plus x is negative 3x. Well, that is the correct number, but wrong sign. So we need to flip the signs. X times 4 is 4x. Negative 1 times x is negative x, giving us positive 3x. So we were able to factor it. And again, if we're able to factor the numerator at all, we need to make sure, to verify there are no like terms. Here there are. We have an x minus 1 and x minus 1 in common. And since we do, they will cancel, leaving us with x plus 4 over 2 times x plus 3. Since there's nothing else left in common, that is our final answer. Questions on this here? Let's look at the next one. 5x minus 1 over x squared minus 3x plus 2 minus negative 2x minus 1 over 2x minus 4. And again, the first thing we need to do with both of these here is to factor the denominators. We need to factor them down so we can see what we need to do to make them be the same. 3, or x squared minus 3x plus 2, there is no greatest common factor between these three terms here. So we do our 2 sets of parentheses. We do 2 sets of parentheses because there are 3 terms, and we do have a quadratic. Since the third term is positive, our signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are x and x. Only factors of 2 are 1 and 2. Now at this point here, we can check and make sure that we do get negative 3x. X times negative 2 is negative 2x. Negative 1 times x is negative x. Negative 2x minus x is indeed negative 3x. That is the middle term we wanted. So our x squared minus 3x plus 2 factors to x minus 1 and x minus 2. Our next we're going to factor is 2x minus 4. Well, 2x and 4 have a greatest common factor of 2. And if we factor 2 out of 2x, we get x. When we factor 2 out of 4, we get 2. And we get this here. Questions on this here so far? Least common denominator, we need to get these to be the same. And again, the first thing we should look for is the numbers out in front or expressions outside of our parentheses. The one on the left does not have anything, but the one on the right has a 2, so we don't have to do much more than have our 2. Now we can look at our sets of parentheses, these expressions. One on the left has an x minus 1. The one on the right does not. And since it's only listed once in any of these here, we just have it once. Now we can look at the other expression, which is an x minus 2. We have it once in the one on the left, once in the one on the right. So we only need it once. Which gives us this least common denominator. It tells us what the two denominators need to be for us to be able to subtract these from each other. We need 2 times x minus 1 times x minus 2 on both. Because if we have this here, we can be able to add or subtract them. We can combine them into a single expression. If we look at the one on the left, it has the x minus 1. It has the x minus 2. The only thing it's missing is the 2 in front. The one on the right, it has the 2. It has the x minus 2. It's missing our x minus 1. Because if we do this multiplication of 2 over 2 on the left, the x plus or x minus 1 over x minus 1 on the right, we will get the denominators to be the same because our 2 times x minus 1 times x minus 2 here becomes 2 times x minus 1 times x minus 2. The numerator, we can distribute this 2. We can multiply our 5x minus 1 by 2. Our 2 times 5x is 10x. Our 2 times negative 1 is negative 2. Giving us this here. Our other side, it's going to be better if we write this out. We have 2x minus 1 times x minus 1. If we want to, we could distribute it out at this point. Let's multiply them together and then distribute here. And if we distribute this out, our negative 2x times x is negative 2x squared. Our negative 2x times negative 1 is plus 2x. Our negative 1 times x is negative x. And our negative 1 times negative 1 will be plus 1. Now at this point here, we can combine like terms. We won't have any like terms on the left-hand side. If we did, we would have already combined them. But the numerator on the right-hand side, negative 2x squared, does not have any like terms. Our 2x minus x is going to become plus x plus 1. Questions on any of this so far? Now our denominator, since the denominators are the same, we can add, or in this case, we're going to subtract the numerators. So we're going to take our numerator of 10x minus 2 and subtract from it our negative 2x squared plus x plus 1. Now we do need to be careful when we subtract. Our first expression, 10x minus 2, is just going to stay that there. But we do have to apply this negative to all three terms. Our negative 2x squared is going to become positive 2x squared. Our positive x is going to become negative. Our positive 1 is going to become negative 1. Because once we do this, we can now combine our like terms. Our 2x squared does not have any like terms, so it stays 2x squared and we put it in front. 10x minus x is going to become plus 9x. And our negative 2 minus 1 is negative 3. And we get this here. Now again, at this point, we need to see if we can factor the numerator and see if it's factorable. And if we're not sure, again, we can check our b squared minus 4ac since it is a quadratic and there is no greatest common factor. Our b this time is 9. Our a is 2. Our c is negative 3. We're taking the number and the sign. And we can plug this into a calculator and see what we get. We can say second square root. 9 squared minus 4 times 2 times negative 3. We get square root of 105. We get a decimal. So what that tells us is our 2x squared plus 9x minus 3 is not factorable. There is not a greatest common factor. So that is as simplified as it gets. Questions on any of this here? Questions on anything we've done so far? Yes, and we're finished tomorrow.